Hi everyone. I can see we've got about 35 people in the audience now. Welcome to this PV Tech webinar in partnership with PVcase. I'm Will Norman. I'm a senior reporter at PV Tech, and I'm going to be hosting this presentation and discussion on maximising solar project accuracy. First things first, some housekeeping. We're going to have... Hi, Juan. We're going to have an audience Q&A section at the end of the discussion, and I may chip into the presentation with my own questions or questions from the audience. So please do write any questions you have throughout the webinar in the questions tab at the bottom right of your screen, just next to the chat tab there. The webinar will be made available after the fact, so you can go back and rewatch that on PV Tech's website. We're going to be hearing from Hector Lucas Foraste, who is pre-sales engineer at PVcase, about the future of solar PV optimization and the potential for digital twin technology in the PV industry and PVcase's offerings therein. Before that, though, I'm just going to give a brief introduction while people get settled and set the scene. So in my daily coverage for PV Tech, we're seeing more and more stories come across our desks about PV optimization and performance, whether it's through weather or site selection, site planning, trackers versus no trackers, or the performance of the modules themselves. There's a definite trend towards the performance of plants and eking the most power possible from solar modules. From a journalist perspective, I'm inclined to wonder whether that's in part because the technology is already known and well established, and the areas of interests have now become the detail and ensuring that the technology which will drive the next decade of the global energy transition, namely solar PV, is performing at the peak of its powers. Beyond that, though, there's a real business reason for this, because the basics of PV plant construction, engineering and procurement are known. Expertise and refinement, what a sports analogy might call the 1%, really matters. To that end, digital twins are an interesting field for this sort of activity. Hector will tell us a lot more about them in a moment, but in essence, the ability to produce a digital twin, which is a digital replica of a physical entity, product or system, can allow vastly more accurate predictions and models for a PV site and save on efficiency loss in the development and planning process, as well as in actual plant operation. Examples in the PV industry do exist, but they're relatively few and far between. And more parties involved in large PV projects want real-time data and year-round predictions to map out their assets over its lifetime before they put the stakes in the ground. Those different parties are often procuring different data, losing time and information between one another, and ending up with suboptimal projects, which, in theory, a digital twin can really help with. That's enough from me. I'm just about ready to hand over to Hector from PVcase. First, please do remember, as I said, that we're doing a Q&A at the end of the webinar. So put any and all questions in the box to the bottom right of the screen, and I'll get to as many as we can. And without any further ado, Hector, if you'd like to join the stage, and we'll hand over to you.
Yeah, absolutely. Well, thanks, Will, for the introduction. And before anything else, thanks to PV Tech and, of course, yourself, Will, for this invitation. It's really a pleasure for me to be here today. And yeah, basically, that's going to be the topic of today. You actually did a really good summary of what we're going to be checking today. And of course, from my end, I'll try to be as clear as possible, and I'll try to navigate through this presentation and to go through the topic of maximizing solar projects, right? Accuracy by using our solution called Yield, which is basically related also to the digital twin technology. So that's going to be the main focus for today. And as Will was mentioning, if there are any questions as we go, we will tackle that through the presentation and through the webinar today. So once again, I'll try to be super clear and to cover everything as we go. So that being said, we're gonna have an agenda for today, of course, in which I'm gonna be talking about many different things. The first thing, of course, is to cover a little introduction about PVcase, especially for those who are less familiarized with what we do and what is PVcase overall, right? Then, of course, I always like to talk a little bit about the solar industry challenges with, which sometimes it is very clear, but also it's not bad to actually go through that again to see if things are aligned with our ideas and how things are actually looking in the current state where we are, right? So that's going to be one of the things that I would like to go through. Of course, in relation to the main topic, we will talk a little bit about the PVcase vision in terms of the digital twin, right, and why we are having this conversation today, and we are going through this in this webinar. And of course, by the end of the presentation, we will cover the main features and the key factors on how we actually promote this optimization or actually maximizing accuracy during the project development and design through Yield. And of course, I will share some recent and future updates from us so that we can close this presentation after we go through everything. So that's the main idea. So yeah, PVcase is basically what we're going to be checking today, and us as a company, we are trying to help as many people as possible through our different solutions. So basically, for those who don't really know what we do yet, so we cover everything through the project development and design. I always like to say that we cover everything from the beginning till the end when we are trying to develop our projects and when we are trying to design everything from the beginning till the end, right? And we have a solution for each of the different phases. So as we can see here, we have a PVcase Prospect, which is the first tool that we would probably use to cover the site selection and of course parcel search overall, and of course the buildable area analysis to truly understand how those sites are actually for us and for developing the project. So truly understand what I can use in those parcels. That would be questions and things that Prospect will answer. Then of course we have PVcase ground mount and PVcase roof mount, which are our solutions that target the proper geometry and design of the PV plants that we are designing. PVcase ground mount for the utility scale projects in like solar farms, like in ground, right? And then we have roof mount for the rooftops, but it is basically the main idea. And then Yield is our simulation engine, and this is basically the main tool that we're going to be checking today, and that's going to be the main driving factor for us to go through the webinar, right? To truly understand what we have here, why Yield is important, and of course what we can achieve or accomplish while using Yield in our project development and design, right? And this is the main idea. So this is how it is summarized in this portfolio, coming from Prospect till the end, reaching Yield, so that we can cover all of the different phases from the project development until we reach the in-detail engineering that we are looking for through our solutions. And this is more or less what we do and what we are trying to do. And of course, the main idea is that we do the everything in the most efficient, the most automatic way, right, to help everyone that is involved in those phases that we were mentioning before, right? Now, there is something very, very important for me to share here today, and it is actually this graph that we can see in the presentation, which is something that I am very happy to share today, especially because we finalized a, let's say, customer survey that we did through our, let's say, customer portfolio. And we were checking and trying to understand what effect, PVcase has in the daily basis of our customers. And this is very important because, as we can see, when we compare detailed layouts, or when we are talking about detail engineering and preliminary layouts, right, we can see that if we compare the usage of PVcase in contrast to traditional methods, we have a significant time reduction after all, right? And this is very nice because we can see that for detailed engineering or detailed layouts, PVcase help our customers to reduce up to a 89% time reduction overall. And for preliminary layouts, we are talking even, or we are talking almost to 100% in time reduction, right? Meaning that we, the usage of PVcase brings something very valuable to the table, and that we are really helping our users on a daily basis. Now, I don't want this to sound, like the sales pitch of Hector coming here today and trying to sell PVcase. This is actually something that it is true. It is something that every day I hear from our customers, and this is something that we share through our customer stories section in our main page. So once again, this is not only because it is me coming here and telling this. If you really want to learn more about this and maybe check if others are facing similar problems to the ones that you are actually facing nowadays, you can go to the customer stories section in PVcase, and we have there all of the different feedbacks, the stories that all of our customers are sharing on a daily basis. So I truly recommend going on to this in case you want to learn more about that, right? Now, one of the main things that we have to talk here today is the solar industry current challenges. And once again, since we are all from the industry, we know what we are all facing when we are working day after day, right? But I always like to summarize how everything looks like right now, right? If we jump and we see everything from the bigger picture, how things are looking like. And for me, the way I see the solar industry is something that can be summarized in four main sections or four main tabs, as we can see here. The first one is that the PV industry is complex, of course. Like, there are many different things that we have to consider overall when we are working in our designs and when we need to make decisions and so on. And this is something that potentially brings some errors, and this is something that we know, and that's why in PVcase we are trying to do things in the most efficient and automatic way in order to avoid those human errors, for example, which is obvious that we can all do, right, in order to counteract or tackle the complexity, right, in a way. At the same time, it is a dynamic environment overall. There are different parameters that we need to consider, and of course, when we have reliable solutions, then we are capable of doing proper analysis and calculating everything as expected and in the most realistic way, of course. And if we do things like that, then we are capable of achieving proper results, which is basically the outcome that we are all looking for, right? At the same time, since there is a lack of standards in a way, there are a lot of different tools that they are trying to tackle the same things. So basically, this means that one user can actually do many different approaches depending on the different solutions that they are using. And this sometimes is not actually integrated in a same environment or in a same workflow in a way, meaning that there might be some compatibility issues, and at the same time we can even lose information throughout the process, right? So overall, we are talking about a high level of complexity, and maybe there is nothing in the scene that helps users to do things in the most optimal and easiest way possible, right? And this is something that we are trying to tackle with our solutions and basically through our philosophy, right? But this is basically question. Yeah, Will.
So that's just you just made me think of a question there where with all this complexity and PVcase, your four solutions, kind of, you say you cover from the start to the end. How can you link them together? Is there a connection you can make between them?
Exactly. Yeah, and this is actually one of the things that we're going to be checking today. For example, Yield is connected to ground mount, right? So we can basically send our designs directly onto Yield without any issues, and this will come in a couple of minutes. But that's the idea, exactly. So we have integrated everything in what I like to call like the PVcase environment or the PVcase product suite, where we can basically jump from one stage to the next one or come back, of course, without any issues, and most importantly, without losing information. And I think that this is something very, very valuable, especially when we have to consider not only different phases throughout the project development and design, but at the same time, when we are working with many different people involved in the process, many different departments overall, or even different companies working alongside, this timeline from the beginning till the end, right? And this is something that, at least in my humble opinion, I think that PVcase, I mean, we have done a really good job over here, because with just a couple of clicks, we are able to bring everything directly from, from the beginning till the end once again. And that's the main idea. And somehow we reduce, that level of complexity that we are talking about. But nevertheless, Will, it's a really good question, because here we see, let's say, theory in a way, like this is something that we might hear or that we are aware of, but we actually were able to analyze and to get visual representation on how this complexity looks like. And this is something that we obtained in 2023 in Barcelona during Solar Quality Summit. PVcase carried out one workshop there during that event with the different stakeholders or personas, or like the people involved in this workflow that we are talking about, like developers, EPC companies, O&M players, asset managers, engineers, investors, and so on, right? And we were able to understand how many interactions they have along the whole process, right? And what we see here in this representation is the different interactions that they have in the industry right now. The lines that we see on top is the information that one player is sending to the other one, right? Whereas the lines underneath are the ones that represent information coming to me, right? So you can see how many connections we have right now in the industry. And if we don't have something that let's say collects or somehow organize this complexity, we have a full mesh of different interactions where a lot of things can go wrong. And this is something that we are trying to avoid by having this product suite that we have, right? And trying to have everything connected in this environment that I was mentioning before, right? And that's the main idea. Now, in relation to this, and this is another main topic in this webinar today, is the concept of digital twin. And this is why it is very important to talk about this and try to find solutions like a digital twin in the PV industry, because with something like this, we are able to solve many of the issues that we have, not only in the early stage phases, but also during the construction phase and reaching the end of O&M, right? Operation and maintenance, right? Because with something like a digital twin, we are able to control everything. Now, for those who are less familiarized with what a digital twin is, right? It is basically a twin, right? From a reality, a digital representation of an asset that we might have. And talking about the PV industry, we are talking, of course, about a virtual representation of the PV plant where everything is collected. Like we have all the information that we require to truly understand what we are doing, where everything is, right? And how everything that we require to proper manage the site or the asset is there for us to find everything without any issues. That's more or less the concept, right? Now, the thing is that with PVcase and our vision and our approach on this is that we are trying to find ways to make this happen in the most suitable or easiest way possible. And that's why with our solutions right now, we reach the level of the digital model in a way, right? Which is something that we can do through the design stage and also the simulation and performance calculations that we are able to achieve, right? And this is the prior stage until we reach the construction phase, because when we are in the construction phase and we continue till the end until we are in O&M and so on, those are the phases where the digital twin is finally built through all of the information that we add during those phases, right? And the idea is that if we have something serving as an initial point of contact in a way, then we can somehow build this digital twin in the most easiest way possible, right? So for me, the digital model could serve as a skeleton in a way of the digital twin, and through time, as we continue through the construction phase and we reach the end result of the asset, right, then we can control exactly, for example, where the module A120 is in this site and where the frame is over here, and then we can understand how everything is going, if we need to change something, if some workaround has to be done in during the O&M phases and so on, and everything is there in the proper design and in the proper digital twin representation of the PV plant. And of course,
so it's
this, go ahead, Will.
Is there how kind of real time is the digital twin data? Can it continue while the project's running?
Yeah.
And kind of give you constant
information. In theory, it should be something that it is live, right? And it is completely transparent to the reality that we see on site, right? So the idea is that if we have that information there, if some, let's say, maintenance has to be done on certain modules because we need to change those based on, I don't know, for example, hail that we might have due to climatic consequences, right? We know exactly where those modules are, which references we have for those. For example, when we had the last, let's say, cleaning service in the installation and so on, and we can target exactly the location and the materials that we have on site. And when we do that, that information can then go directly to the digital twin, and we can update those changes or those updates in the end, so that anyone that it is involved in the process or in the project overall, they can check that live and say, okay, so today we changed module 1000, and tomorrow we're going to be changing the cables, whatever, based on this. And this is something that serves everyone in the end, to actually manage and to control the site without any issues. And this is something that we see from PVcase, that it is relevant and it is important for the industry, because there are other let's say, industries in the end that they are using this, like, for example, in the car industry or industrial engineering. It is something very common that many companies are using nowadays, and we see that there is a lack of this in the PV industry, and that's the main idea. We not only try to do, to accomplish or to somehow work around this concept through our, let's say, solutions, but at the same time, we are part of different institutions and different, let's say, programs trying to achieve this. So, for example, PVcase is part of the Trust PV program, and also Supernova, trying to achieve this sort of goals that we are talking about, the digital twin. And we are working in collaboration with very relevant stakeholders and companies in the industry, trying to accomplish this. So we are trying to be really active, trying to see what the industry requires nowadays for this, and of course try to make the best solution based on that feedback that we receive, right? And this is the perfect example about this. So, for example, in the Trust PV article that I share here, we can see that this is a representation of a real plant that we can visit nowadays. So this is working nowadays, and this is the representation that we do with the Yield, like this solution that we are talking about today, where we can clearly see that reality is actually something that we can virtually represent through our simulation engine. And the idea is that if we extend this concept, then we can somehow reach this somehow level of digital twin idea that we are looking for through here. So I really wanted to share this because this is a really good example of how reality can become something tangible through our solutions in a way, right? And this is basically what we are going to be talking about today. And this is the main idea. Yield, what is this about, what we are capable of doing, and so on, right? So, for anyone who never heard about Yield, Yield is our simulation engine, and with Yield we are able to actually calculate and actually control how the PV plant will actually perform based on the design that we are actually doing in CAD, right? In PVcase ground mount. And the idea is that we serve certain key factors here that makes the difference in order to truly understand what's going on with our PV plant. For example, we are able to generate a full 3D representation of the PV plant, which is very important. At the same time, we use something called ray tracing optic technology to actually understand how those photons will interact with our PV plant, right? And at the same time, if we have an electrical design in place, because we are doing that on ground mount, we are able to track and understand, for example, the non-uniform mismatches that we might have on a cable level, right? So those are things that truly help anyone who's really interested in really understanding how the PV plant is working. With those features, for example, we are able to accomplish that. Now, these tools, as we were mentioning before, they work together, and we have this environment generated through this integration, PVcase, ground mount, and yield, where we are able to generate multiple iterations, for example, in PVcase ground mount, in order for us to optimize our design. And the idea is that while we do this model comparison and decision making, we can select multiple iterations from here and then click on export. And when we click on export, we get a message successfully exported to the Yield cloud, meaning that everything that we are designing in CAD appear directly on our Yield platform, meaning that we have access directly to those layouts, as we can see here in this video, where we can visually see in a 3D model how the plant is actually performing. And we have all of the details and all of the things that we are designing in CAD, where we are actually able to truly understand throughout the day and throughout the year how all of those assets and how all of those elements will perform in order to achieve the energy production that we are looking for in the end. And that's the main idea. And once again, with just one click, we are able to send this information directly onto the platform, meaning that there is no time waste, and at the same time, we don't lose information throughout the process, right? Now, the main topic for today is, okay, we want to talk about maximizing accuracy, right? Because we have seen what PVcase is capable of doing, the different solutions that we have, the challenges that we have nowadays in the industry, and of course how Yield actually performs and how this integration is looking like. But now we need to understand how we actually improve this accuracy during the design stage overall. And for me, there are five main key factors, which the first one is the seamless integration that we have here in our hands, which really allow us to run this process of model comparison, project optimization, decision making, completely automatic without any issues, with just one click. And that's super useful when we have to consider multiple realities for our project. And this is something that we do, once again, in just one click, and most importantly, without losing information. The second thing that we need to consider, once again, is that we work in a full 3D representation of the PV plant. And I think that this is very important in relation to other solutions in the industry, because we are really capable of understanding how this 3D model and this reality is performing here. I don't know if you have a question, Will. I see that you unmute yourself, or is there a question?
Oh, no. Just,
okay.
Yeah.
Perfect.
Not yet.
So the idea is that with this 3D simulation model, we are able to basically understand how complex terrain models, for example, will perform with our PV plant. So if we have complex terrain models with bifacial modules, for example, we are able to track and understand how things are looking like, because this 3D model serves as a basis for the ray tracing optic technology, meaning that we have control in the different positions that the sun will have throughout the year, right? And then we are able to track those rays or those photons and simulate how everything will perform in reality. So this is very nice to have accurate results on everything, and of course on how my PV plant is going to be performing, right? The fourth and almost last feature, which is the coupled thermoelectrical computation, is also very interesting, because we have the possibility to bring complex designs from CAD into a full 3D representation in the cabling in this model. And this means that if something, if we really want to achieve very precise results, we can bring those designs that we are doing in CAD. So for example, we are talking about in detail engineering, right? Like we have full control of everything. We can send everything directly onto Yield, and we can track those non-uniform mismatches. And this is definitely very, very useful to get to proper results in the end. And the idea is that once again, with this iteration engine that we have there in ground mount, and how this seamless integration works, we are able to send those multiple realities in a matter of seconds. And I can compare, for example, 50 different results or 100 different results for the same site and the same parcel, and maybe consider, okay, I want to compare fixed tilt versus single axis trackers, and for example, versus east-west, right? And see which is the most optimal reality from all of them. So this is something that we can do without, wasting time. We just set the parameters, we click on iterate, and we generate those, let's say, realities for us. And then with just one click on generate, as we can see in the video, we can create those as we go. And that's very, very useful, because in the end, if we send those 50, 100, 200 different iterations to Yield, we can run those calculations in parallel, and we save in the end a lot of time, of course, to get to those results, which is basically the outcome that we are looking for in the end. So because of those 5 key factors, right, we truly believe that there is a huge increase in maximizing the accuracy in the project development and design. But once again, I don't want this to sound like the sales pitch. This is not something that I say. This is something that we have been checking with other companies, with our customers and so on. And one of those cases is the benchmark analysis report that Black & Beach did last year, or well, it was 2023 exactly, where they actually compared PVcase Yield to PVsyst. And not only they share the results in this article, but at the same time they explain the main differences of both simulation engines. And I basically suggest anyone who's interested in learning more about this, please scan the QR code so that you can check out the article yourself. And at the same time, we also have the let's say product guide. This is some of the recent public articles that we have been working on in PVcase, where we even share real data that we have achieved or that we have accomplished through Yield. So basically, once again, this is more information that you can check out at any time. So if you are also interested, please check the QR code. And of course, if you have questions, we will be always there for you. And that's the thing. So we have been talking about many different things, challenges, how PVcase works, how Yield works, and why we are actually very precise in what we do. But the main question is, okay, so what's next in the future, right? Like, what are we going to be doing during the next couple of weeks ahead? So I have future updates. Actually, some of them are already released. So for example, the mixed single axis trackers and fixed tilt plant simulations. It's something that we already have implemented in the platform. The same as the single diode model update. So those are things that we have already implemented in Yield, so that we can improve our experience while simulating our PV plants, right? And then we have something coming very, very soon, which is the probability estimates integration that will be super useful, for our users to run, for example, financial models and work with P50, P90 simulations and so on, and check the different results that we get through that. So that's going to eventually come in Yield very, very soon. So the idea is that with this sort of updates, we were very precise, but now we're going to be even more precise in the end. And this is something that we do on a regular basis. So each a couple of weeks, we update the tools in order to provide the most suitable and the best solution to all of our users, right? And that's the main idea here. And this is probably everything from my end reaching this point. So the only thing that I can say, Will, and of course to the rest, thank you very much for the time and the opportunity to be here today. And I am here to hear all of those questions if there are any. But yeah, once again, thank you for the time.
That was great, Hector. I was going to ask you a question a second ago, but then I didn't want to interrupt. But I was wondering about. It seems that it would be really useful to people in terms of the relationship of PV with the grid, because that's increasingly becoming complex, right? Like there's increasing amounts of curtailment, particularly across Europe. You've got the integration with storage. You've got more complex tariffs, things like that. I wonder if you could speak about that, maybe how the increased accuracy. You know, like I'm thinking of the ray tracing, the year-round ray tracing. How that can help with managing power output and managing the kind of the grid.
Absolutely. Well, first of all, with this sort of features, what we do is like we achieve a let's say high resolution result in our outcomes. So we basically get to a PDF report which is very precise about how the PV plant will be performing. So that's the best thing out of Yield. But in relation to the grid, for example, and so on, one of the things that we can simulate here is the grid limitation, for example, or how the grid will perform in a way when we connect it to the plant. So if you have that information, you can set up those parameters there as well as many other losses, right? And you can simulate exactly how the PV plant will perform in the end. So if we are truly looking for let's say high-end results or very reliable results, PVcase Yield is the tool for me. And not only because you know, I work at PVcase, I was doing this job before coming to PVcase, and I know how challenging it is sometimes to achieve those sort of results. And with this sort of technology, we are able to accomplish that. So that's very, very nice from our end.
I want to turn to a couple of audience questions we've had. One from, well, two from Kevin R, but they kind of combine into one, which is kind of how automated and how AI driven is the PVcase software, and then secondarily to that, would using PVcase Yield be more automated than PVcase ground mount?
Yeah.
Or would you?
Yeah, absolutely. Yeah. So I think that it is a very straightforward answer. PVcase, like the level of automation that we have in PVcase is very, very high overall, but we don't have AI, at least for the time being, right? We have features that work somehow similar to what we could probably get with AI integrations, but we have done it in-house in a way without using AI, if this makes sense, right? So for example, being able of generating multiple iterations or being able to represent, let's say, mechanical designs or even electrical designs in the 2D and 3D environment without any, let's say, handwork in the end, is this level of automation that we are trying to bring to the user experience, that we do completely automatic through the features that we have, but we don't involve AI, let's say, generation or anything like that, at least for the time being. Nevertheless, or that being said, this doesn't mean that we might consider, you know, having something like this in the future. This is of course something that I don't really know. That would be a question maybe for product and so on. But since AI is already there and everyone is using, let's say, this sort of technology, it wouldn't be strange to, you know, to consider, you know, PVcase having some sort of extra help on that. But nevertheless, at least in my humble opinion, if we know exactly what we are trying to do here with the features that we already have, you know, with Prospect, ground mount, roof mount, and Yield, we are very capable of doing projects in a couple of minutes. And that's the level of automation that we have here. The only thing that we have to do is to, let's say, shift a couple of parameters or customize a couple of parameters that serve as reference for us to generate the layout and generate the design that we are looking for. But that's the only thing that we have to do. Apart from that, the whole, you know, the program does everything for us, and that's very, very nice in the end.
Yeah. Got a question here from Kazra, who asks, is there a plan to integrate BESS features?
Yeah, that's a really good question, and there is, and it's actually one of our priorities. I'm also waiting for that for sure. I'm really excited about this, and this will be part of PVcase very, very soon, because the team is already working on this. I know that the first updates will come in PVcase ground mount. So first of all, we will be able to design the facility or the, let's say, the place where we're going to be placing those containers or those BESS systems, right? And we're going to be able to connect them in the electrical design overall, right? And the idea is that once we have that update in ground mount, then the team is also working in integrating that directly onto Yield. And that's going to be very nice, because with that, we are aiming to control and simulate how the battery will work with the PV plant. We will be able to simulate those hybrid projects, even consider, for example, load shifting, peak saving, and so on. Very important features in relation to batteries. And once again, this is something that we are working on. So I really hope that we see an update on that. I don't have a timeline for that, unfortunately, because that's not in my hands. But I know that the team is working really hard on this. So pay close attention, because I'm really sure that we will have something very, very soon for that.
Yeah, there's a question here which has stolen one of mine.
Okay.
But so we've seen more and more, particularly on PV Tech, the news we cover, more and more reports of kind of issues around degradation of modules and the kind of emerging issues from you can argue why they come about. Some people say it's the kind of price crunch means that people, they're not the products they once were. And Ed Saldana has asked if the simulation PVcase Yield takes into account panel degradation over time. Yeah,
absolutely. We have one parameter for that, which we have to set up in the losses section. So that's for sure, we can do that. And there's also a very interesting feature that we can also customize, or loss that we can customize, which is the one in relation to the degradation in terms of soiling loss, for example, and the environment. And this is something that we can, for both, if I am not mistaken, we can not only provide inputs or parameters on a linear way, like, for example, say, okay, in my simulation, we're going to consider 1%, degradation or value in loss. We can also provide a value per month, and we can, for example, for the soiling loss, we can even consider when we're going to be managing the cleaning services for the maintenance of those modules, and how those will be performing throughout the year. So that's the level of control that we have here. So that's why we provide really high resolution results in the end, because we are able to control that sort of features in the end.
A similar question actually from Javier, which is can PVcase Yield estimate PV cell temperature? Because obviously that can affect output performance.
Yeah, that's also a really good question. We do consider that, but the problem is that I don't have a full answer to that. I'll try to explain this in the best way possible. We use a temperature model, or let's say regulation model in temperature, of course, which is based on IMEX model. So it's sort of an integration that we have done previously, and we are able to understand how the temperature goes or shifts based on the materials that we have in the cells, and also the ambient temperature that we have in the surroundings. So we are able to simulate how this affects the performance of the module, right? And of course, how in the end this affects production and so on. This is more or less what I remember from this topic. But nevertheless, if we have more questions about this, or we require a more in detail explanation about this, feel free to to text us, send us an email, or contact us, because we can share more information about this in detail. All right.
Yeah, I should have mentioned that earlier actually. PVcase, you've said that you're willing to you can answer people's questions in more detail on email or in direct contact after this webinar.
Or even myself, like I will be available through for example LinkedIn or email or whatever. Let us know, and we will try to answer everything more into detail if it is required. Yeah.
There's a couple more that I think we can get to. It's actually another one from Javier who asks if you can detail how the ray tracing model affects the photons which hit the ground. Obviously, you've mentioned the bifacial. You can account for bifacial modules.
Yeah.
And he asks, are they reflected with the same incidence angle, as in like in a mirror, or if the approach is different?
Yeah, that's also a good question. I believe that I'm not going to be able to answer fully to that because I don't know exactly how the model responds. But I know that we take into consideration that reflection, not only in the ground, but also in the modules themselves, like how the photons will be reflected from the front end of the modules to the back end of the, let's say, the next ones, right? So we are able to consider that, but I believe that I'm not going to be able to answer fully on that, on how precisely we do it. So I suggest, Javier, if you have more questions about this, let us know, and I can, contact the product team of Yield to go exactly into detail and see how we do it. Or, of course, go through a demo or a trial phase if this is of an interest, and yourself check and see how everything performs. That's always a possibility.
There's another question here from Rainer, and I'm not sure. Well, maybe you will have an answer. We'll see.
Okay.
About asking what options are there to incorporate or simulate load demand, and if so, are there any means to cater for thermal demand or load? I think that's referencing back to when you were discussing the potential for BESS.
Exactly, yeah, for batteries. And I believe that we are talking about, in the end, about load curves, like if we are talking about self-sufficient models, or exactly about the grid. Yeah, that's a really good question, and that's gonna come eventually. Like, we are not able to simulate that for now. But it will, because once we release the batteries, we require the load curve exactly to understand how the production and the excess will be delivered in the batteries and how the whole system will perform. So it is something that we are working on, but for the time being, we are not able to simulate.
Yeah. I guess we're running low on time now, but I think I wanted to ask as well. It's a different, slightly different type of question. But earlier in your presentation, when you had the results from your solar quality workshop that you've done in Barcelona, how did you do that? And how did you collect that data and then kind of simulate that level of complexity? Because it's really striking, to see how convoluted the process is.
Yeah, absolutely. And I'm going to say that this is a simplistic model or representation of how the real complexity looks like. Because when we are talking about this workshop, we try to show that result, but we have an internal graph where we see exactly how those interactions are, and it's even more messy than what we saw. So that's a really good question. So what we did is, like, we carried out a let's say blame game. I would say that was the name that we gave to that workshop, and everyone that was attending Solar Quality Summit that year and that they were in the workshop, we organized them in those personas or in those stakeholders, right, in those groups, and then we were discussing with each one of them, a couple of questions, like, okay, so how do you work nowadays? Which are the corresponding let's say players that you require on your daily basis? Where do you need the data coming from, and where is it actually missing, or what's going on here, and so on. And based on their answers, we were able to generate this representation, this map, right, this mesh of those interactions, and this is where those results come from. So anyone that attended Solar Quality Summit that year and that they were part of that workshop, they gathered into different groups. We shared them a couple of questions, and based on that data, we elaborated that results from the blame game.
Yeah. Okay. Well, I think if there's no more audience questions, I'll give everyone in the audience a last chance to get some questions in. I think there's not much more else to say other than to thank you, Hector, for such a kind of enlightening and interesting presentation.
Thank you.
And for making it clear that it's not a sales pitch, because it's just true, which is nice. And thanks to everyone who's been in the audience and who's taken part. As we mentioned earlier, if you have any further questions or you want to go into any more detail, you can contact PVcase or you can contact Hector directly, I think, to discuss some of those. And eventually, I think in the next couple of weeks, this webinar will be available to view. So yeah, thank you everyone for attending. Thanks for coming. And yeah, I hope to see you all next time.